Hi everyone, this is Ruchi Kulkarni. Today we are going to do the chapter The Making of a Scientist from class 10th book Footprints Without Feet. This story is about Richard H. Ebright, who is an American molecular biologist. Richard was born on 11 June 1959 and grew up in the town named Reading in Pennsylvania, USA. He used to collect butterflies as a child in kindergarten as he grew up. He experimented on various things. He won various awards and was also able to discover a hormone that monarch butterfly's pupa produces for its full development. This study helped him find how cells read their DNA. He had other qualities also. He was a good speaker, a debater, photographer, and canoer. He is the Board of Governors Professor of Chemistry and Chemical Biology at Rutgers University and Laboratory Director at the Waxman Institute of Microbiology. Let's read how this curious child who collected butterflies went on to become one of the greatest scientists in the world. So in today's session, we'll read and understand the chapter along with its difficult words, understand significance of the title, moral given by the story, its summary and question answers. But first, let us know about its author, Robert Peterson. Robert W. Peterson was born in 1925 in Warren, Pennsylvania. He was an American newspaper writer who later became a freelance author of magazine articles and books, especially on the topics of sports and scouting. Peterson played baseball while attending Uppsala College. He was a writer and editor with the old New York World Telegram newspaper, which folded in 1966. He also wrote numerous articles for scouting magazines in 1970s till 1990s. Peterson died of lung cancer on February 11, 2006 in Salisbury, Pennsylvania. Richard Ebright has received the Searle Scholar Award and the Schering-Plough Award for Biochemistry and Molecular Biology. It was his fascination for butterflies that opened the world of science to him. In this story, we are going to read about Richard Ebright and how he entered or how his experiments made a stir in the field of science. He entered this world of science because he had a fascination for butterflies. And when he experimented on butterflies, he received the awards called Searle Scholar Award and Schering-Plough Award. He dealt in two branches of science, that was biochemistry and molecular biology. Biochemistry is a branch of science that deals with chemical processes in living organisms, while on the other hand, molecular biology is a branch of biology that deals with structure and function of proteins and nucleic acids which are important to life. So in today's chapter, we are going to read about Richard Ebright, about his experiments, about his achievements, and how highly he is regarded in the world of science. So let's start with reading the chapter. At the age of 22, a former Scout of the Year excited the scientific world with a new theory on how cells work. Richard H. Ebright and his college roommate explained the theory in an article in the Proceedings of the National Academy of Science. It was the first time this important scientific journal had ever published the work of college students. Journal means a magazine or a newspaper. In sports, that would be like making the big leagues at the age of 15 and hitting a home run your first time at bat. Making the big leagues means in a field of tough competition, you do your best, or whatever achievement you have made, it is the best of all. So this phrase home run in a game refers to baseball game where the batter scores a run after running safely around all bases and back to the home plate without stopping. For Richard Ebright, it was the first in a long string of achievements in science and other fields, and it all started with butterflies. An only child, Ebright grew up north of Reading, Pennsylvania. Reading is the name of a place. There wasn't much I could do there, he said. I certainly couldn't play football or baseball with a team of one. But there was one thing I could do: collect things. So he did. And did he ever? Beginning in kindergarten, Ebright collected butterflies with the same determination that has marked all his activities. He also collected rocks, fossils, and coins. He became an eager astronomer too, sometimes stargazing all night. Stargazing means looking at the stars with the help of a telescope. Richard Ebright, at the age of 22, surprised the whole world when he explained a new theory on how cells work in a living organism. He made this theory with the help of his roommate, and it was the first time in the history that his article or his theory was published in a very popular scientific journal. So for Richard Ebright, it was one of the many achievements that he had achieved later in his life. And he feels that all of this started because he became curious with butterflies. Richard grew up in Pennsylvania. The town's name is Reading. He was the only child of his parents, and he could not have done much there as there were very less people living there. So he says that he could only do one thing alone, and that was collecting things, because he had no friends to play football or baseball with him. So it was not just collecting butterflies, he also collected rocks, fossils, and coins from the time when he was in kindergarten. He also used to keep on staring at the stars, and sometimes the whole night, as he was interested in studying astronomy also. From the first, he had a driving curiosity along with a bright mind. Driving curiosity means desire to gather information or being very curious. He also had a mother who encouraged his interest in learning. She took him on trips, bought him telescopes, microscopes, cameras, mounting materials, and other equipment, and helped him in many other ways. I was his only companion until he started school, his mother said. Companion means friend. After that, I would bring home friends for him, but at night we just did things together. Richie was my whole life after his father died when Richie was in 3rd grade. She and her son spent almost every evening at the dining room table. If he didn't have things to do, I found work for him. Not physical work, but learning things, his mother said. He liked it and he wanted to learn. And learn he did. He earned top grades in school. On everyday things, he was just like every other kid, his mother said. By the time he was in the 2nd grade, Ebright had collected all 25 species of butterflies found around his hometown. Now, Ebright had always been curious to learn new things, and he had a sharp mind, and his mother used to encourage him to learn. So she used to take him on learning trips. She used to buy him telescopes, microscopes, other instruments that would help him in learning new things. His mother was his only friend until he went to school. And after he started going to school, his mother would get his friends home. He and his mother used to spend a lot of time together. They stayed together at night, and they used to do and learn things together. Ebright is also nicknamed as Richie by his mother in this paragraph. For this mother, her son Richie or Richard was her whole life and support system after his father died when Richard was in 3rd grade. Both mother and son used to spend most of their evenings together. If Richard did not have anything to do, his mother would find him some task for learning. So he used to like the learning work that his mother used to give him. Richard was a very bright student because he scored good in class, and also he was regular in his daily tasks. And by the time Richard was in 2nd class, he had collected all 25 species of butterflies which were found around his hometown. That probably would have been the end of my butterfly collecting, he said. But then my mother got me a children's book called The Travels of Monarch X. That book, which told how monarch butterflies migrate to Central America, opened the world of science to the eager young collector. At the end of the book, readers were invited to help study butterfly migrations. They were asked to tag butterflies for research by Dr. Frederick A. Urquhart of the University of Toronto, Canada. Ebright's mother wrote to Dr. Urquhart, and soon Ebright was attaching light adhesive tags to the wings of monarchs. Anyone who found a tagged butterfly was asked to send the tag to Dr. Urquhart. The butterfly collecting season around reading lasts 6 weeks in late summer. If you are going to chase them one by one, you won't catch very many. So the next step for Ebright was to raise a flock of butterflies. He would catch a female monarch, take her eggs and raise them in his basement through their life cycle from egg to caterpillar to pupa to adult butterfly. Then he would tag the butterfly's wings and let them go. For several years, his basement was home to thousands of monarchs in different stages of development. Now, after Richard had collected about all the 25 species of monarch, he thought that it would have been the end of his butterfly collection. But then his mother got him a children's book called The Travels of Monarch X. This book told how the monarch butterflies migrated to Central America, which was the turning point for Ebright as it turned his curiosity towards science. Now, at the end of this book, the readers were invited to help study butterfly migrations. So they were asked to tag butterflies for research by Dr. Frederick A. Urquhart of the University of Toronto. Ebright's mother wrote to Dr. Urquhart, and soon Ebright was attaching tags to the wings of monarch butterflies. And anyone who found a tagged butterfly was asked to send the tag back to Dr. Urquhart. The butterfly collecting season around Reading Town would last only for 6 weeks in late summer. And if one was supposed to chase every butterfly, then one may not catch very many of them. So then Ebright thought that this was pointless, chasing every butterfly. So he thought of raising a flock of butterflies. He would catch a female monarch butterfly, take her eggs and raise them in the basement of his house. So the entire life cycle of that butterfly, that is from egg to caterpillar to pupa and then to adult butterfly, happened in his basement. And within no time, he would have adult butterflies flying about in his basement. So for several years, his home's basement was a house to thousands of monarch butterflies, and all were in different stages. Eventually, I began to lose interest in tagging butterflies. It's tedious and there's not much feedback. Tedious means a long and slow process. This was said by Ebright. In all the time I did it, he laughed. Only 2 butterflies I had tagged were recaptured, and they were not more than 75 miles from where I lived. Recaptured means captured again or recovered. Then in the 7th grade, he got a hint of what real science is when he entered a county science fair and lost. County means region. It was really a sad feeling to sit there and not get anything while everybody else had won something, Ebright said. His entry was slides of rock tissues, which he showed under a microscope. He realized the winners had tried to do real experiments, not simply make a neat display. Already the competitive spirit that drives Richard Ebright was appearing. I knew that for the next year's fair, I would have to do a real experiment, he said. The subject I knew most about was the insect work I had been doing in the past several years. So he wrote to Dr. Urquhart for ideas, and back came a stack of suggestions for experiments. Those kept Ebright busy all through high school and led to prize projects in county and international science fairs. Now, after raising monarch butterflies for several years in his basement, Richard got very bored. He soon started to lose interest in tagging butterflies because it was a very slow and tiring process. And he said that out of many butterflies that were tagged, only two could be recaptured by people, and those two were not more than 75 miles away from where he lived. So they were very far off. Then, when he was in 7th class, he came to know that what real science was when he went to county science fair. He saw people experimenting there and winning rewards, but unfortunately he did not win anything because others experimented, they showed something, whereas Richard only displayed frog tissue slides under a microscope. So he realized that if he had to win an award, he really had to do some experiment in the next year's fair. So he thought and realized that he would take up the subject of insects because that is what he had been studying for a long time now. So he wrote to Dr. Urquhart for more ideas, and Dr. Urquhart responded him with a lot of ideas for his next year's project. He remained busy with those ideas all throughout his high school, and he won many prizes throughout. For his 8th grade project, Ebright tried to find the cause of a viral disease that kills nearly all monarch caterpillars every few years. Ebright thought the disease might be carried by a beetle. Beetle is an insect, a type of insect. He tried raising caterpillars in the presence of beetles. I didn't get any real results, he said, but I went ahead and showed that I had tried the experiment, and this time I won. The next year, his science fair project was testing the theory that viceroy butterflies copy monarchs. The theory was that viceroy look like monarchs because monarchs don't taste good to birds. Viceroys, on the other hand, do taste good to birds. So the more they look like monarchs, the less likely they are to become a bird's dinner. When Richard was in 8th class, he tried to find the cause of a viral disease that killed all monarch caterpillars every few years. So Ebright thought that the disease was being transmitted through insects called beetles. So he started raising caterpillars in the presence of beetles just to check whether he was correct or not. But it was of no use. But when he showed that he had tried such an experiment, he won something for his project. For the next year, he tried the theory that viceroy butterflies copy monarch butterflies. The reason being that they both look similar. He put forward this theory that viceroy butterflies look like monarchs because monarchs do not taste good to birds and the birds like to eat viceroys. So the more the viceroy looked like monarch, the less likely is that viceroy butterfly would be eaten by birds. Ebright's project was to see whether, in fact, birds would eat monarchs. He found that a starling is a type of bird, who would not eat ordinary bird food. It would eat all the monarchs it could get. Ebright said later research by other people showed that viceroys probably do copy the monarch. This project was placed first in the zoology division and third overall in the county science fair. Zoology is the scientific study of animals. Now, once Richard realized that viceroys look alike monarchs for the same reason that they should not be eaten by a bird. In the next year, he wanted to show in his project that would a bird eat monarchs or not. He found that there was this sterling bird who would prefer eating a monarch butterfly. And later, the research showed that viceroy butterflies copied monarch butterflies in their appearance. So this project won him the first division in the zoology department and the third overall position in the county science fair. In the second year in high school, Richard Ebright began the research that led to his discovery of an unknown insect hormone. Indirectly, it also led to his new theory on the life of cells. The question he tried to answer was simple. What is the purpose of the 12 tiny gold spots on a monarch pupa? Pupa is an in-between stage of larva and adult butterfly. Everyone assumed the spots were just ornamental. Ornamental means for decorative purposes. Ebright said, but Dr. Urquhart didn't believe it. To find the answer, Ebright and another excellent science student first had to build a device that showed that the spots were producing a hormone necessary for the butterfly's full development. This project won Ebright first place in the county fair and entry into the International Science and Engineering Fair. There, he won third place for zoology. He also got a chance to work during the summer at the entomology laboratory of the Walter Reed Army Institute of Research. During his second year of high school, Richard started a research from which he found about an unknown insect hormone which later helped him in his new theory about the life of cells also. The question from where the research started was very simple. What was the purpose of the 12 tiny gold spots on a monarch pupa? Most of the people thought that these spots were decorative, but Dr. Urquhart did not believe in what others said. To find the answer to this question, Ebright and another excellent science student together made a device that proved that these spots produced a hormone which was necessary for full development of butterfly from a pupa. So with this, Ebright won the first prize at the County Science Fair and the entry to the International Science and Engineering Fair. Now there his project won third prize for zoology, and he also got a chance to work at the entomology laboratory of the Walter Reed Army Institute of Research. Entomology is a study of insects. So when he got a chance to work at the laboratory, he could work more on his experiments in that lab. As a high school junior, Richard Ebright continued his advanced experiments on the monarch pupa. That year, his project won first place at the International Science Fair and gave him another chance to work in the Army laboratory during the summer. In his senior year, he went a step further. He grew cells from a monarch's wings in a culture and showed that the cells would divide and develop into normal butterfly wing scales only if they are fed the hormone from the gold spots. That project won first place for zoology at the International Fair. He spent the summer after graduation doing further work at the Army laboratory and at the laboratory of the US Department of Agriculture. The following summer, after his freshman year at Harvard University, Ebright went back to the laboratory of the Department of Agriculture and did more work on the hormone from the gold spots. Using the laboratory's sophisticated instruments, he was able to identify the hormone's chemical structure. Richard continued his work with the monarch pupa as a high school junior, and that led him to win the first prize at the International Science Fair. After winning this prize, he also got a chance to work at the Army laboratory during summers. So then, during his senior year, he tried another experiment in which he grew cells from a monarch's wing in a culture and showed that the cells would divide and develop into a normal butterfly wing scales only if they are treated with that hormone from the gold spots. This research of Richard won him the first prize at the International Fair, and he spent his summer after graduation doing more research on the subject at the same Army laboratory and the laboratory of US Department of Agriculture. Then he worked some more on the hormone released from the gold spots during the following summers at the lab. He identified the chemical structure of the hormone using the lab's special equipment. Now let's read ahead. A year and a half later, during his junior year, Ebright got the idea for his new theory about cell life. It came while he was looking at X-ray photos of the chemical structure of a hormone. When he saw those photos, Ebright didn't shout, "Eureka!" or even, "I've got it." Eureka is a cry of victory at a discovery. But he believed that along with his findings about insect hormones, The photos gave him the answer to one of biology's puzzles: how the cell can read the blueprint of its DNA. DNA is the substance in the nucleus of a cell that controls heredity. It determines the form and function of the cell. Thus, DNA is the blueprint for life. Ebright and his college roommate, James R. Wong, worked all the night drawing pictures and constructing plastic models of molecules to show how it could happen. Together, they later wrote the paper that explained the theory. Surprising, no one who knew him, Richard Ebright graduated from Harvard with highest honors, second in his class of 1510. Ebright went on to become a graduate student researcher at Harvard Medical School. There, he began doing experiments to test his theory. After 1.5 years, Ebright got the idea for his new theory, and that was about cell life. The idea came to him when he was looking at the X-ray photos of the chemical structure of the hormone. He did not get excited, but he came to a realization that his years of study on the insect hormone had solved one of the puzzles of biology. It had solved the mystery of how cells read the blueprint of its DNA. And he found that as the DNA is the nucleus of a cell that controls heredity, therefore it determines the form and function of a cell. And therefore, DNA was the blueprint of life. Then Ebright, along with his roommate James Wong, made drawings and plastic models for the theory which showed how it was possible. And later they both wrote a paper which explained the process. He graduated from Harvard with highest honors. So Richard Ebright displayed his intelligence, his smartness, his dedication in other subjects as well. It was not just scientific experiments but also in studies. He then became a graduate student researcher at the Harvard University, and he also started doing practical experiments in the university's lab to test his theory. If the theory proves correct, it will be a big step towards understanding the processes of life. It might also lead to new ideas for preventing some types of cancer and other diseases. All of this is possible because Ebright's scientific curiosity. His high school research into the purpose of the spots on a monarch pupa eventually led him to his theory about cell life. Richard Ebright has been interested in science since he first began collecting butterflies, but not so deeply that he hasn't time for other interests. Ebright also became a champion debater and public speaker and a good canoeist, an all-around outdoors person. Canoeist is a person who is skilled at racing canoes. He is also an expert photographer, particularly of nature and scientific exhibits. In high school, Richard Ebright was a straight A student. Because learning was easy, he turned a lot of his energy towards the debating and Model United Nations clubs. He also found someone to admire, Richard A. Wehrer, his social studies teacher and advisor to both clubs. Mr. Wehrer was the perfect person for me then. He opened my mind to new ideas, Ebright said. It was expected that if Richard's theory proved to be correct, then it would be a big step towards understanding the complex system of life, and it would also lead to new ideas for preventing certain types of cancer and other diseases. So this showed how his research on the monarch pupa led him to a theory about cell life. He had been keen in science ever since he started collecting butterflies, but this did not keep him away from other interests. He was a champion debater, he was a good public speaker, he was a good boat racer. He was also an all-round outdoor sports person, along with being an expert photographer. He was great at capturing nature and scientific subjects. And as he was a great student and always used to score good, he used to focus his extra energy on debating and on Model United Nations clubs. He also used to admire his social studies teacher, Mr. Richard Weyler, who was an advisor to him for both the clubs. So Ebright thought that his teacher was the right man, as he was the one who used to open his mind to new ideas. Richard would always give that extra effort. Mr. Weyler said, "What pleased me was, here was this person who put in 3 or 4 hours at night doing debate research, besides doing all his research with butterflies and his other interests." Richard was competitive, Mr. Weyler continued, but not in a bad sense. He explained, Richard wasn't interested in winning for winning's sake or winning to get a prize. Rather, he was winning because he wanted to do the best job he could. For the right reasons, he wants to be the best. And that is one of the ingredients in making of a scientist. Start with a first-rate mind, add curiosity, and mix in the will to win for the right reasons. Ebright has these qualities. From the time the book The Travels of Monarch X opened the world of science to him, Richard Ebright has never lost his scientific curiosity. Richard's teacher, Mr. Weyler, was impressed with the fact that how Richard would give an extra 3 to 4 hours of effort every night for the debate research, apart from the time he used to give for his butterfly research and other interest also. So he added that Richard was competitive, but he wasn't competitive in a bad sense, because he did not want to win prizes just for the sake of winning. Rather, he wanted to be the best at whatever he did. And this is what makes a good scientist. A good scientist needs a first-rated mind, along with curiosity, and also will to win for the right reasons. Since the time Richard's mother got him the book about migration of monarchs, his curiosity towards science has just grown. It has never stopped. The title of the story, The Making of a Scientist, aptly suits the story, as it is a journey of a student who learns by experimenting and moves on to discover what was unknown to all scientists. The story tells us that success is not something one may achieve in a day, but it is a gradual process. We learnt in this chapter that Richard Ebright had to undergo a journey of a scientist whose interest and pursuing the same led him to discover and bring some great changes in the world of science. Richard faced many failures in this process, but his great mind, curiosity, and will to win resulted in the making of this great scientist. This chapter gives the message that hard work always pays off. If one shows dedication, perseverance, and determination, success isn't impossible. Richard was an exceptional child with rare qualities of intelligent observation and keen interest in the nature of things. The curiosity of a child should never be curbed or discouraged. So if we provide logical answers to the child's queries, then it will help develop a scientific way of thinking and problem-solving skills in him. We must encourage their analytical and logical thinking, because that's the correct learning procedure. That's all in today's session. Continue ahead for summary and question answers. It's time now for me to wrap up this session. If you like learning with me, please like, share, and subscribe to my channel. And I'll see you again in my next video. Till then, take good care of yourself and God bless you.